Problem number 8. For any object thrown upward from a given height h, measured in feet with an initial velocity v measured in feet per second, the equation below can be used to find the object's height after t seconds. And they give us a formula that says height equals negative 16t squared plus vt plus h. So this kind of looks like what we have studied, and then it kind of doesn't. We're used to something that looks like, actually let me put it up here. We're used to f of x equals ax squared plus bx plus c, where a cannot be 0. So it kind of looks familiar, but then it doesn't look familiar. So let's keep reading. A ball is thrown into the air from an initial height of 32 feet with an initial velocity of 16 feet per second. Which table describes the height of this ball? Well, they tell me that the given height is the spot where the ball leaves the person's hand. This is the given height. That's denoted by the letter H. And initial velocity is used with the letter V. So what if I go ahead and substitute this information? We know negative 16t squared is supposed to be there. That's part of the formula. But I want to look for an initial velocity. That's this V letter that's not familiar to me at all. And if I look over here at my story, it says an initial velocity of 16 feet per second. So I'm going to substitute 16 for V, velocity, because they tell me to use 16. T is part of the formula, and then the given height is something they give to me. It's a given height. So when I look back at my story for the given height, I see that it is an initial height of 32 feet. So someone is standing at a height of 32 feet on a platform or something. That is the given height. So this is looking much more like what I'm used to. I'm just going to write it in function notation. So the height of the ball in terms of time is this function. Okay, that looks much more like what we're used to. In fact, we can find our a, b, and c values for that function. A is negative 16. That makes sense because this ball is falling in this story. That's a parabola that's frowning. B is 16 in this problem. And C is 32. That's where the graph of this story would cross the y-axis. Okay, and we're not having to graph it, so it's not going to be important. I just want you to know how to read those values. So I'm going to have to evaluate this function, which means that I need to choose some input values. Normally we would call those x's, but in this problem they're t's, they're times. So I'm going to look at my table here to see which input values I need. Because remember, we want our inputs to match their inputs, or we won't be able to compare the tables. So they used these inputs for the first table, and then look at what happens. They use those inputs for the second table. The inputs are different. So my first instinct is to say, oh my goodness, am I going to have to do all of those inputs? I can do that. I could list every one of those input values that's not duplicated, but that's going to be a lot of them. Let's look at all of those that we would have to do. We would have to put a 0, a half, a 1, a 1.5, a 2, a 3, a 4, and that looks like all of them. That would not be terrible. It would just be 7 of those inputs, which we've done before. But there's another way on this one, and you can do all of the inputs if you want to. When I worked this problem, I did almost all of them. But let's look at this a different way and see if we can shorten this. Let's do a test-taking strategy. I know that the tables are all different, but is there a value that the tables have in common? In other words, all of the tables have a 0. That's actually the y-intercept, but the thing is that all of those 32s are the same. So the 0 is not going to help me. We already know that the ball is at 0 time, the ball is at 32 feet. So that's really not helping me at all. So let's look to see if there's another value that is in all 5 tables. So let's move to this one. It's in that one, but not this one. So that won't help. But look at this. There is a 1 in each of these inputs. All right. This one is linked to 64. This is 148, 132, 164, and 164. I'm going to evaluate my function at 1 and just see if that might help me. So let's see, rather than have to do all 7 inputs, let's see what happens at 1. So I'm going to say h height at 1 second is negative 16 times 1 squared plus 16 times 1 plus 32. So this would be negative 16 times 1 plus 16 times 1 plus 32. So negative 16 plus 16 plus 32. So this would be 0 plus 32. So the height at 1 second is 32 feet. So let's look at our values over here and see which one matches. And I already see it. This was a good strategy because there's a 1 that I put in and there's a 32 that I got out. So I know that my answer is C. You can evaluate all 7 of them if you want to, but you don't have to. And if we were just learning how to do this, I would probably do all 7. But I think you guys have seen enough of these that you probably don't want to do all 7. But this will work to give you the answer of C.